Hello, welcome, and an excellent evening. We again have a Commodore 1541 floppy disk drive. The owner is the same person that also had the last drive in the Double Trouble feature with the C64. Actually, the drive back then came once more back to me because something else broke down in there and it got the full replacement. It got a new rectifier, full bridge rectifier, and a new filtering cap just to be on the safe side. And that finally fixed it, I think. Plus there was something else, I think there was one more broken inverter chip. So something went wrong somewhere along the line. But that's old news. This is new news. This is a supposedly non-working drive. It has a little bit of a bump here. There might be something else broken on the case, so it probably got bumped pretty hard or something. And it's supposed to be one more drive that has power but does not stop spinning. Let's check that. It's plugged in. Power light comes on, drive light goes on. You can hear the motor spinning, but nothing else. So that's the usual problem that we also had last time. It can have different causes, of course. It might be missing 5-volt rail. It might be CPU not coming out of reset. It might be broken CPU. It might be a broken ROM. And there's a ton of reasons why this can happen. But it doesn't help to guess. So we'll have to open up the drive and check out what's inside and see what's actually happening on the mainboard and check for the different voltages. I think the screw in that last hole might be slightly stripped, so I have to be very careful with that one. Yeah, I'm gonna need a bigger bit. Yeah, I think I got it. Let's check that screw. And yes, it is. I'm not sure if you can see that. It is somewhat stripped. So someone used the wrong screwdriver here, I think. Sometimes you can still get it out with a slightly too large a tip. So here we are. This is the disk drive, and it actually looks interesting. I think maybe someone else was in here before, because we have at least one or two things that are interesting. First of all, we do have chips from 1984. The main CPU is a 6502B, which is interesting. I think this one goes up to 3 megahertz. Is of course not used here. It's only run at 1 megahertz. From 1984, there is a Rockwell VIA chip from 1990, so this must be a replacement. And there's a UMC 6522, also a VIA. These are both the same chips. From 1987, also replacement, I would say. The Gatorade chip is, I don't know from when, but it's original MOS part, still soldered. This is the SRAM, and these are the ROMs, the drive ROMs. Both are MOS labeled and are from 1984 by the looks of it. So I think these are original and these two are probably replacements. This one here, I don't know, but SRAM chips are not that big of a deal. The capacitors, this big one here is a Nichicon, which is great. This is probably just fine. This one here is a Unicon. It's at least not a Fraco, which was the failing one on the last drive. So I guess they might be fine. So the first thing that we should do is to check and see if we have 5 volts, I would say. So pin 8 on the CPU should be 5 volts. And that does not look like 5 volts to me. Not at all. So maybe there is no 5 volts. We also can test on one of the 74 ICs. So I'm now on one of the 74 ICs down here. You can't see it. Maybe I'm going up here. So the last pin on this side should always be 5 volts. And this doesn't look to be the case that we have any 5 volt here. So the first issue that comes to mind is the voltage regulator. Not the voltage regulator, which is also a possibility, of course, which would be this one here, but the bridge rectifiers. And these are the two bridge rectifiers, and they do occasionally fail. There's one for the 5 volt line and for the 12 volt line, and they might have an issue. The 12 volt one should be okay because it is working, the drive is spinning, so the 7812 is seemingly just fine. But we can test in diode mode the other one, and we have to look up which of these, the CR1 or CR3, is the actual bridge rectifier that is used for the 12 volt rail. Another option would be that one of the AC outputs of the transformer is broken, but I haven't seen that yet. More likely it's the bridge rectifier. There's of course also the possibility that the 7805 has failed. That would also result in no 5 volt. It could also be that the smoothing capacitor is broken, that it is shorting to ground or something like that. But I would guess that the fuse would then blow, and these big caps don't really fail that often. So I would currently assume that we have an issue with the bridge rectifier. So let's look up which of these is the correct one. You can look up the schematics for the board. This is a assembly 250442, and on zimmers.net you will find the schematics for that. Okay, so it seems that CR1 is the bridge rectifier in question, and if we look at the good one and we measure, for example, between the middle two legs, we get 0.6. On the CR1 we get 0.5. Might be okay, not quite sure. Let's test the outer two legs. Oh, we are measuring not in diode mode, I think. This is now correct. Okay, this is much better. If we measure the outer two legs, this is the DC output. We get something that is charging up because it's connected to the smoothing capacitor. That is looking fine. Here we get 0 volts on the AC, and on this one we also get 0 volts. I guess we would have to desolder these to get a proper reading. Okay, if we measure from the plus side to the AC side, we get 0.55 volts. On this one roughly as well. Minus to AC, we get the same here and the same here. So they do look fine so far. So I would guess at the moment that this might be an issue. We can test the AC, the DC output, which should be, I don't know, significant, for something around 9 or 10 volts, I guess. Let's switch to voltage DC, turn on the drive, and it's outputting 11.7 volts. So the bridge rectifier seems to be working all right. On the 12 volt line, this will output something higher, like 19 volts almost. So the bridge rectifier is working just fine. We could look with the oscilloscope and see a rectified unsmoothed signal on this side, I guess. So my current guess is that the 7805 has actually failed, which would be, I think, another drive with a failed one, because I did have one earlier this year. So let's desolder this and swap this out. So I took the board out and already unscrewed one of the fasteners. These are usually put into place with two fasteners. On older drives they would use rivets, which is completely annoying and not very serviceable. So you have to unscrew these and keep those screws, because these are actually the ground connection of the voltage regulator. And how can you desolder these? It's best to have a desoldering gun. If not, then it's a bit more tedious, but definitely be doable. You need some fresh leaded solder. You heat up one leg and put some fresh solder on there, so we get some fresh flux and stuff in there, and yeah, it makes just flowing of the old solder much more easy. The desoldering gun and my soldering iron are roughly set to 350 degrees. The nozzle here is slightly too small for the thick pins of these, but barely fits over. And then very noisy desoldering later. This comes off actually very nicely. And this is looking really good. The pins are rather thick, so it will probably stick a little bit to the sides. I'm gonna zoom in a little bit so you can see that. The pins are sticking here to the through hole, so I'm going to push them very, very gently away from the sides with the soldering iron. You will hear a little click or cracking sound when the solder gets hot enough so that you can remove it. And then I carefully wiggle it. It's not coming loose yet because it's still sticking a little bit to the side. I'm gonna heat up the other leg again. And I think now it's free. There we go. And they do use some heat compound, heat spreader, whatever, and an isolating plastic sheet here. And this is the voltage regulator. We can turn off the desoldering iron now. I can zoom out a little bit. And there you go. There is the board. What we can do now is we can try and test the voltage regulator with the power supply that I've got here. And it will probably maybe check out fine. The last one that was broken seemed to be fine when run without load. We are inputting 19 volts, that's way too high. So we were inputting something like 11 volts, right? So I'm gonna put it to 11 volts, turn it off, and we will clip onto the ground lead here. And one of the pins is the input and one is the output. So this one here on the left, let me zoom in a little bit. This one here on the left is the input. As you can see, this is asymmetric. The pins are a little bit lower, and there is this round structure here up here. Might be that the chip is actually under there, I don't know. But this is where it comes in. Then we will also take our digital multimeter, and I'm gonna put it into voltage DC. And we'll need some crocodile clips. Okay, I've attached some crocodile clips, which go onto the ground and the output. And that should, in theory, be enough to measure this thing. Let's turn it on. And we're seeing 10 volts on the output. That's actually not very good. Let's switch it off very quickly. This might indicate that this thing has failed short, which is interesting because we don't see that on the 5-volt rail actually. So we might be in luck that there might be something akin to a crowbar on that. But what might that be? There is nothing in there. There's only smoothing capacitors. So something seems to be shunting the 10 volts down to ground. And I wonder what that is. Interesting. But this seems to indicate that this one failed. I'm not gonna turn it on again, even under no load. It seems to be doing not that great a thing. Very interesting. I'm wondering if I measured incorrectly, but this should actually be okay, I think. Oh well. I would say we put in a good voltage regulator and then test this whole thing again. The thing is, there's only, I think, one of these capacitors here that should be C6 and C5. C16 is on the input side, so this is on the input side, and C6 and C5 are on the output side, which is this one, and I would have assumed this one. It seems to be something different. Well, there's a couple of capacitors definitely on the output side. And the question would be, did any of these 10 volts arrive at the chips and destroy something? Because it could also be that there is a short, of course, to ground via one of the ICs. That is actually something that we could test if we have a short or near short. For that we will need our multimeter again and use the regular probes. So we're gonna put it into ohms mode. And what did we say? One of the 74 ICs, like so. And ground should be, I think, here. So this is measuring at 0.2, obviously. And I think pin 1 on the 6502 should actually be ground. And we see 400 ohms between 5 volts and ground. I'm not sure this is that great. On the vias, I'm not sure this is very healthy. Question is, yeah, what is a healthy drive doing? I'm gonna pick a healthy drive and look inside of that and measure what the resistance between 5 volt and ground should actually be. All right, this is a healthy but definitely older drive with all kinds of replacement chips that I put in there. I think I put in new VIA chips here because they were broken or missing, I forgot. But we can definitely test what the 5 volts versus ground looks like on this device. Let's turn it around just like we did on the other drive, and I'll put this over here so you can see everything. Oh my god, is this heavy. So this should be the 5 volts, and the ground should be here. And we do see 1.4 kilo ohms. So definitely significantly more, but it's not a dead short either. Plus, this is a slightly different revision of the drive. So it might be normal, which is of course a bit hard to tell. But the 300 ohms still seem a tad bit low for me. Let me check if I have a similar revision board. And here we finally got it. This is another assembly 250442. And this should be very, very much equivalent to the board we are working on. Let's check what this looks like. And here we also have 1.3 kilo ohms. So I would say there is something shorting more or less to ground. Not quite shorting, but definitely making it very hard for the voltage regulator to push a lot of current through the board. What I would do is, there seem to be quite a couple of replacements already. I would pull out the chips, the ICs that are on here, mark them with their respective names like UC2 and so on, so I know where they came from, and see if that soft short disappears. Because I have a feeling that if I put in a good voltage regulator, just like so, it will probably destroy the new voltage regulator as well. I'm gonna put this drive away for the moment and take the other board here. Oops. Take this board here and then start pulling ICs. Because I fear there is a different fault. This one, the voltage regulator, is definitely bad, I would say. But if I put another one in there, it might pull way too much current and destroy the new voltage regulator as well. So let's pull these one by one and see if it changes anything. The issue is there's of course a ton of ICs that are not socketed. So one of those might also be at fault. It might also be one of the capacitors that are on the 5 volt line that failed. Probably shouldn't be, because I think they have quite a high rating. The disk capacitors, definitely, they should go to like 50 volts or something. So I would assume that most probably one of these chips got fried, which is actually bad news. But maybe one of those failed chips protected the others by shunting the voltage down to ground, because as you saw, the voltage regulator actually couldn't deliver any voltage. It might also be that this basically under no load outputs more or less the input voltage, but breaks down to 0 volts when it gets under load. That would be relatively good news. But the main issue with these boards is they don't have a crowbar circuit, which means if the voltage regulator fails short, the input voltage gets directly onto the ICs, which is very bad news indeed, because it's around 11 volts, something like that, which is of course not good, which is where actually the new voltage regulators by Mr. Floppy come in, and I think I have one here in the bag. These are the switching voltage regulators, which are, well, not liked by so many people because they say this will make switching noise, but these are actually ultra low noise, so they don't affect the 12 volt or 5 volt line at all, measurably, and should work just as fine. They run much cooler, and I think these also have some kind of protection, and they shouldn't fail in such a way where they put the input voltage on the output side. I hope, at least. I think that's how it works, but I might stand corrected. Okay, I'm gonna start pulling chips. I'll do that off camera because that's pretty tedious and boring, and I'll tell you if I see any change in behavior. I'm sure some of you were already shouting at their screens. I just thought I'm gonna start by pulling the 6502 CPU. And there was definitely somebody in here before. Beside the replacement ICs, the CPU has a notch on this side. This marks pin 1. And there is a notch on the PCB, of course. Let me zoom in. The notch is here. The CPU was in like so. And it belongs like this. And I'm gonna put a lot of money on the fact that right now, if I measure, the short will be gone. Actually, no. No, I think probably on on the wrong pins. I have to get my pinouts here. So VCC is over here and ground is over here. And we do still see, you can't see that. We do still see not the 1.3 kilo ohms I am wanting to see. But my guess is that this CPU is fried because it was inserted backwards. Which is not that big a deal because 6502s can be had very easily still. But I'm wondering if this damaged more than that. I'm gonna check the pinout for the 6522 to see where we find the ground on that. That's pin 1, definitely, yeah, that's pin 1. So VCC should be on the last pin here. Oh, I should just leave this running. And pin 1 should be that. That's what we tested, right? And not on voltage, but on ohms. Yeah, that's not looking so great. For reference, I'm gonna put the quote-unquote good drive here and measure again. Maybe I did measure something incorrectly. And we do see, oh, we see the same. So I was measuring, I think, between these two pins, and I think, yeah, okay, sorry, I measured the wrong thing. I didn't measure the VCC on the 74, but some arbitrary input. So we do see the same ohms reading. So I went on a chase there that was completely unnecessary because it seems I didn't get enough sleep last night, and this is not exactly great. So if that's the case, we can actually try and see if this chip still works. If that's the case, we can definitely put a new voltage regulator in, because that means there is no short, but this one is still dead because it outputs 11 volts. I'm going to leave the CPU out for now, but I'm going to pick up a new voltage regulator. With new, I mean new old one that I desoldered and replaced with a switching voltage regulator. I'm not going to put this in here because I need them for other projects, and I'm going to leave this as much original as I got it. But all in all, I can definitely recommend those because they run cooler. But before I know that everything is working fine here, I don't want to spend any expensive components, because these new voltage regulators are roughly 10 euros a piece. So they're actually much more expensive than just picking an old one that you salvaged, which I'm gonna do right now. Okay, I found a replacement one. This is a Fairchild UA7805KC, which also came from one of my floppies. It is from 1984, so it seems to be from one of the 1541s. And I think we can just leave the thermal grease on here. I wouldn't put any new one here just yet. We're gonna put in at least one of the screws. And yeah, this is looking actually rather suitable. It's a bit finicky to get the nuts back on. Tighten it with your thumb, just very lightly. Then you can fasten it a little bit more with a screwdriver. Where is it? Over here. And since there's one of these toothed rings on there, it should tighten itself pretty well, and dig a little bit into the solder or copper on this side and make good contact with ground, because that's actually pretty important. Otherwise, if it's floating, it will not work. There's a lot of metal here, so it will have to heat up quite significantly. Takes a while. Now it's hot enough. Leave it there for a second. Same here. Heat it up for 5 seconds or so. Flow some solder in. Let it settle, and there you go. This should make very nice, good contact. And we should be able to put this back together preliminarily and check for the voltages. I'm not going to put in the CPU yet if it has developed a fault, like a short or something, which we actually did not quite see. And I'm not gonna attach the read heads so as not to put them into any danger. I'm gonna attach one screw here because it will help with the heat distribution from the voltage regulators, because then the heatsink makes contact with the metal frame of the chassis. And I'm gonna put in one more screw over here, I think, because that's also ground, so that the case is properly grounded if the screw wants to go in. Actually, no, this does not want to go in. This screw seems to be slightly damaged. Let's check this. Yeah, this seems to go in just fine. My hope would be that we don't need to take this board out. This will go here. I will plug in these because these are all the 12-volt connections, etc. I think we probably only need this to see the drive spinning. Plug in some power. And now we're gonna pick up, I'm gonna put this over here. Put this into voltage DC. I'm gonna pick 2, 4, 6, 8. We probably also measured incorrectly the voltage because we measured at pin 8 over here, so that was completely wrong, and we probably would have seen 10 volts on the whole thing. That actually explains why we did see only 0 volts. So I'm fearing that this might have all the chips broken if we are unlucky. Let's check the pinout on the 6502. The sync is on pin 1, so these two should actually show us 5 volts now. And it's 5 volt on the spot, which is very nice. So we don't break anything by plugging in this If it has a short, the fuse should blow. But maybe this even survived this terrible catastrophe that is whatever this person before us did here. 2, 4, 2, 4, 6, 8. No, 2, 4, 6, 8. Okay. This should be correct. And it's still dead, obviously. Okay. We might have a ton of faults on this. Maybe this is a complete write-off. We'll see. We do have 5 volts restored. Now it's up to us to determine which chips died. For that, we will need the oscilloscope. First, we will check to see if the reset is working. All right, we are back with the drive, and the voltage regulator has been swapped out, as you know. There is a new CPU in here because I think the other one is completely broken. And I don't know if it's so broken that it broke the voltage regulator or the other way around, because I put the old CPU back into my test drive and it wouldn't work after that anymore either. And it turned out that it also now had a broken voltage regulator. So there is something fishy, or I'm just having massive bad luck. But 5 volts are now fine here, and new CPU is in here, but we still have a continuous spinning drive. So I'm gonna record the scope and we'll probe around and see what's happening. So you're seeing the output of my scope now, and we are on the reset pin of the CPU, and as you can see, it is not going high. It is kept in reset. We can check the clock signal to see if there's anything good on that. And as you can see, that's perfect 1 megahertz signal. That is looking just fine. Which means we do have to debug the reset circuit, which is visible in the schematics at the bottom of the screen. If I can manage to unplug my probe here. Of interest here are the IC UD3, which is this one here, which is the last one. It's a NAND gate, and gate pin 6 is the output. So now I'm on pin 6 and there is nothing on there. Pin 5 and 4 are the inputs. 5 is high, which is fine, and 4 is also high, even slightly higher. This is 5, this is 4. So 4 is looking nice because that's pulled up directly to 5 volts, as you can see down here. So this is where we are currently looking at, which means we have to look at UA1. Pin 8 is the output and pin 9 is the input. UA1 is over here. I think you can see that. That's a 2, 4, 6, 7 pin chip. So we are looking at pins 8 and 9. Pin 8 would be the output. That's over here. So let's check that. That's high. Pin 9 is the input, which is low. Okay. So we're currently looking at this part here. This seems to be working. At least it's correct that if this one is low, then pin 8 must be high. There's a diode going up to 5 volts. I already checked that. That's the diode over here. It seems to be fine, reading at least quite normal. And what we are actually looking at here is a low signal. So that should get, I think, pulled high once the capacitor here is charged. That is this capacitor here. Once this capacitor is charged, everything should go to high. As long as this is charging, this will pull the whole line low. There is also everything before R57, which is the inverter buffers for the external reset, which can come from pin 6 on the IAC bus. So we can have a look at pin 2 and 1 of UB1 and 2 and 1 of UA1. UB1 is the one right next to this chip that we looked at 1 minute ago. So the output is pin 2, which is this one here, which is low as expected, and the other one should be high. I can get a good connection. Yes, there it is, high. And pins 2 and 1 on UA1 are this here, which is high, and input is low on UA1. So this whole pipeline here of the reset circuit seems to be fine, which leads me to believe that it might still be one of the gates here pulling something very hard to low. So we could try and disconnect R57, which should be somewhere. Here's R55. I have to locate it somewhere. R36. It must be either in the vicinity of this here or over here. Let me quickly look for this. R57 is here. So we can lift one side of this thing, and hopefully this should tell us if it's bad or not, one of the gates there. So what I'm going to do is, I don't want to solder with the power plugged in or anything. So I'm just going to snip the leg of this resistor, which can be easily soldered back if needed. So I think this should be it. We can then lift this thing. So that's disconnected. We are now disconnected on this whole part of the circuit. So in theory, C46 should pull everything low while it's charging, and then this resistor here should pull everything high, which you can also check if this turns out to be a fluke. So let's have a look on the reset pin if this changed anything. Yes, this definitely changed something. We are out of reset, and the drive actually stopped spinning. So if we look at the data lines, everything is back to normal, it seems. This is fine. So probably one of the ICs before that, this one or this one, must be bad, which is actually good news. I was fearing that a lot more was destroyed with the presumably broken voltage regulator and the broken CPU, which was plugged in incorrectly. So the question now is, we have a 50-50 chance, or maybe even a 100% chance if both are broken. Which of these ICs is bad? The question is it the 7406 or the LS14? So we're talking about these two ICs here. They do break quite often. We had issues with those before. And due to the fact that it's probably, I mean, it could start snipping legs here, but it's probably easier if I just desolder both of them, because both are also on the external connector, or let's say not both, but the LS14. I would start by desoldering the LS14, and that should hopefully be the one, because it might have been just, again, an overvoltage coming from the outside and destroying this chip here. The 7406 could also be the culprit. I've seen them die before as well. but who knows. So I'm gonna desolder this one first and see if that fixes the issue. If not, then we'll also desolder this one. This one here also has nice long legs from the looks of it, so it should be easy enough to put a socket in and replace it with in the socket. Otherwise, we put in a fresh new chip if it's broken. All right, socket is installed, chip is removed. It is in the Mini Pro tester, and let's run the test if possible. Mini Pro-P7414-T for test. And there you go. Pin 2 is always low, which is a bad thing. This means that the 7414 is indeed broken. So let me very quickly fetch a new 7414, put that in, and I think we might have a working device then, which is excellent news, because I was fearing that apart from the CPU, many more chips might be broken. So it seems that maybe there was an overvoltage from the outside, fried this chip. Maybe this one failed or didn't, or someone assumed due to the reset not working that the CPU is bad, replaced it and put it in the wrong way, which maybe then fried the voltage regulator, who knows, overloaded it, broke it down due to, yeah, I don't know, having a short and drawing too much current, which didn't trigger the fuse, something like that. So probably the repair here broke more than necessary. I'm not even sure that the vias were broken. Maybe they were, but they got replaced for sure by the previous owner. But I think it was probably all only a broken 7414 due to electric shock on the ports, which is often an issue. So these two chips near the ports are usually the ones that fail. They're basically a fuse for electrostatic shocks. They cost like €1 or €1.50 or something at most. So it's actually pretty cheap to repair them. And yes, Commodore could have put some protection diodes like on the C64 on later revisions on the ports. But they didn't here, so that's that. So yeah, I'll grab another chip, put it in, we'll assemble the disk drive and we'll run it through its paces and test it. The drive is connected to the C64 and I ran the alignment program, which is seemingly really good. Everything is on track. The half tracks are okay. I mostly ignore these, but this will be a drive that will be working just fine. We can do one more check. We can run the speed test. There we go. It's running at 300.2 RPM. This is perfectly, that's spot on, that's just fine. This is an excellently calibrated drive, it seems, and the owner will have lots of fun with it. So it goes back together and will return to its owner. And there you go. That's the whole story. The drive is working. I ran it through a couple of demos. The alignment is fine, the speed is fine, and all that was broken was the CPU and the LS logic chip, the LS14 inverter that is buffering the IEC port. I did check the voltage regulator again, and it seems it was not broken. I used the checkerboard from the DR DOS Reloaded switching regulator, and the checkerboard attached with a 22 ohm load, so it powers at least a couple hundred milliamps. And yeah, it did work after all. So I'm wondering if I did something wrong before. Probably hooked it up probably wrong. And in circuit, I did measure on the wrong pin, as you remember. because the CPU was the wrong way around. I have to review my footage, but I think there was definitely something iffy there. Still could be that the voltage regulator has suffered a bit, so it's probably not too bad that I replaced it. Yeah, but that being said, everything's fine now. I put in a disc for protection of the heads. That's something I heard you should do, and to lock it in place. The drive is really clean. It has one little broken off bit here, but that's not too bad. It will definitely work just fine like that for many years to come, hopefully. All the repairs on these drives are actually pretty nice. Do keep the lookout for drives with the Alps mechanism that you can identify by this garage door mechanism, not the one with the twisty bit here, which are the Mitsumi Neutronics drives, which do tend to have failing read-write heads. The Alps basically don't die, and they have been chugging along for over 40 years now. So they are really nice to have, and they work reliably. And the 1541 is such an iconic drive, I think. A computer in and of itself with quite a powerful CPU. Still, it's very slow, obviously, but there's mods for that as well, software mods and hardware mods, but I'm not gonna go into that. But for today, that's it. Thank you very much for watching. Share, like, and subscribe. Leave a comment down below. And also follow me on Mastodon at chaos.social/@root42, I think, should be the URL, but I would put it in the video description as well. There you can contact me, chat with me, and stuff like that. I post pictures, progress stuff, and etc., things like that. Yeah. Otherwise, see you in the next video. I'm trying to get back to the Let's Code videos as well, but they take a lot of time to prepare. But now that I'm back from vacation, I hope that we can pick that up as well. There's also a lot of other stuff lying around in the background. We have to check when I have time to do that. But yeah, see you in the next video and have a very nice day, week, and so on. Bye!